Hello everyone, today we're going to be talking about dividing polynomials using long division. So this is typically when we are not able to factor, then how are we supposed to actually divide our polynomials? Well, we're actually supposed to use long division, and that's what we're going to be learning today. So for our first problem here, we see that we have our x squared plus 3x minus 43 divided by 8 or x plus 8. So when we actually go through and do this problem, the divisor, the thing we're dividing by, let me do a darker color or a lighter color. So if I have x plus 8, that is the thing I'm going to be dividing by. And then I actually write down my x squared plus 3x within that actual division symbol, 3x minus 43. Okay? So I'm just going to kind of walk you guys through these steps, and then I'm just going to do an example. We're just going to do two examples today. So what you need to actually look for is what can actually make this, what times x will get me x squared. And since we have the 8 attached to it, that means we actually are going to go over two spaces. So I'm going to say that x times x will actually get me x squared. So what I'm going to do is I'm going to multiply x times x, which is x squared, then x times 8, we get a positive 8x. We are subtracting this whole thing. Make sure you put parentheses around that. Just like when we distribute a negative, it has to go to both terms here. So we're going to write our new equal sign, and I have an x squared minus an x squared, which will just be canceled out now. Then I have a positive 3x, and then remember it's going to be a minus 8x now, so now I have a negative 5x. Now I'm trying to determine what x value will actually, what times x will get me a negative 5x. So I have to multiply this x by a negative 5. So now, oh, don't forget to bring down your negative 43, just like in long division. And what we're going to do is having our negative, so now I have a negative 5 times x. I get a negative 5x. Negative 5 times 8, we end up getting a negative 40. Go ahead and make sure you put parentheses around that entire thing. There's your subtraction sign, which means that's going to be distributed to each of these terms, making everything actually positive when I distribute that negative, because they were both negative. That's the only reason why. So now negative 5x plus 5x, those cancel out. And then negative 43 plus 40, we actually have a negative 3. So right here, this is my actual remainder of my polynomial here. And this is how we actually write that. So we have x minus 5 was how nice they went in. That was our above value up there, the actual divisor, or how many it divided in, x minus 5. And then we write our remainder. Since it's a negative 3, you're going to put a negative 3, but then we have to put our actual divisor as our denominator, since we had a remainder. Okay, so this is our final answer. We get our value from the x minus 5 from up top here, and then our remainder is always going to be in the top of the fraction, and the denominator will come from the actual divisor. Okay. So again, you guys, this is some new stuff, so please rewind the video, make it go slower. If I'm going too fast, we will definitely be practicing these more. So now my second example, the missing powers in the dividend. So the dividend is the value that's going inside the division sign. Divisor, dividend. Okay, so we are going to write, let me do a darker color, so we have k plus 5. And what that missing power in the dividend, it says we're going to add in any missing powers with a 0 as our placeholder. What that means is that we are actually dividing, like you said, with our divisor here. So we want to see if we are in standard form. Remember, you want to go from the highest to the lowest degree. So we go from a 3. Remember that little invisible exponent is a 1 there, or the degree, and then our degree on the whole number is 0. So what we want to do, we're missing a 2. We need to go 3, 2, 1, 0. So what we are doing, we are going to put that 0 as a placeholder for the variable that we are missing. So we have our k to the third. that 0, we're just going to put plus 0k squared. Then we can write our rest of our polynomial because we aren't missing anything. So I have k to the third, 0k squared, which is our 2, 17k to the 1, and then our degree of 0 with that 32 constant. So now we have all our polynomials. You have to place it with a 0 if you are missing one. Okay, so what we're going to do first is the same thing. How many times, or what do we have to multiply that k by to get k to the third? Well, that's going to be k squared. Again, I have two terms here, so I'm going to go 2 terms over. That's my k squared. So k squared times k is k to the third. K squared times 5 is 5k squared. Go ahead and put your parentheses around the whole thing. Subtraction sign, remember it's going to get distributed. So our k's cancel out. This is actually a negative 5k squared left over. And then don't forget to bring down your next term. Okay, and then we're trying to figure out what value times k will get me a negative 5k squared. Well, that's going to be a negative 5k. So negative 5k times k is going to be our negative 5k squared. And then we have a negative 5k times a positive 5, which will be a negative 25k. Go ahead and put parentheses around that whole thing. Subtract it. Remember, these turn positive because they're both negative if we distributed that. So now the k's squareds cancel out, and then I have my negative 17 plus 25k, which I'm actually left with 8k. Go ahead and bring down your 32, our last value there. What times k will get me 8k? It's going to be a positive 8 there. So then now 8 times k is an 8k. And then 8 times 5, we get our 40, positive 40. Subtract that whole thing in parentheses. K's cancel out. This is a negative 40 plus 32, so now we have a negative 8 left over as our remainder. So just a refresher on how to write our final answer here, you're going to write your polynomial from the top, k squared minus 5k plus 8. And then our remainder is going to be the negative 8 with our divisor in the denominator. And that is our polynomial that is actually done by long division. Okay, so this is the most key important here, important information to remember, because your answer will come out completely incorrect if you do not forget to do the placeholder. Alright, you guys, I will see you in class. We will practice this more. Have a good day.